Hello everyone, this is Murat and I'm here today to walk you through the construction intelligence brief for the week of March 23rd. The headline this week is simple but significant: Physical AI, meaning AI that operates in the real physical world, has crossed the commercial threshold. This isn't a story about experiments or pilot programs in a lab somewhere. This is about robots and autonomous systems making financial sense right now in the construction industry. What we're looking at today is the beginning of deployment at scale. Let's get into it. So let me frame the three big things that are happening simultaneously this week. First, robot dogs from Boston Dynamics, machines that cost $300,000 per unit, are now deployed at hyperscale AI data centers. Not a trial, commercial deployment. Second, a Canadian startup called Robim Technologies has found a way to bring robotic prefabrication to small and medium construction firms by absorbing all the capital costs themselves. The customer just orders finished timber trusses. They never have to touch a robot. Third, at the simulation layer, Synopsys has launched ANSYS 2026 R1, claiming the first agentic engineering capabilities in a major platform, meaning AI that doesn't just help engineers work faster, but independently explores design alternatives. The thread connecting all three: data center construction is the current demand driver, but general construction is the long-term beneficiary. Let's start with the most visual story of the week. Boston Dynamics quadruped robots, you may have seen the videos online, are now commercially deployed at hyperscale AI data centers in the United States. According to Fortune and Business Insider, Boston Dynamics has seen a massive uptick in interest from data centers over the past year. Their Spot robot is being used for site patrol, hazard detection, things like puddles or leaks, site mapping, and safety compliance. The pricing ranges from $175,000 to $300,000 per unit, and Boston Dynamics says each unit pays for itself within about 2 years at the usage levels these campuses require. Now, why does this matter for general construction? Because these data center deployments are today's cost reduction engine. As volumes increase, unit prices fall. The inspection and monitoring capability being piloted at data centers today is expected to migrate to standard construction sites within 3 to 5 years. We are watching the cost curve bend in real time. The second story is from Edmonton, Canada, and that's where I did my PhD. And it's arguably the most important business model story of the week. Robim Technologies has been selected for Edmonton Unlimited's Venture Pilots program. What they do is robotically prefabricate timber trusses for the modular building sector. But here's the key point: Robim absorbs all the capital and operational risk. Customers don't buy robots. They don't operate robots. They don't need to train staff. They simply order finished robotic manufactured product. So this is a robotics as a service for prefabrication, and it directly solves the two reasons small and medium construction firms have historically been locked out of construction robotics: the upfront cost and the skills gap, both eliminated in one model. If this model replicates, and we think it will, it could extend to steel, modular construction, and beyond. The business model here is genuinely more innovative than the technology itself. The next story is about the coordination layer, and this is the piece most people overlook. Individual robots and drones already exist. You can buy a construction drone today. You can apparently buy a robot dog, but getting multiple autonomous agents to work together on a live construction site without a human operator constantly supervising each one, that is the hard problem. Virginia Tech researchers, working with a named industry partner called Procon Consulting, are building exactly that: coordinated robot and drone teams using AI computer vision for continuous remote monitoring of live construction sites, multiple agents operating together autonomously. The fact that this is an academic industry partnership with a real commercial partner, not just a lab project, suggests the capability is close enough to practical deployment to justify serious investment. Story 4 shifts from physical robotics to the engineering simulation layer. Synopsys has launched NSYS 2026 R1, and it comes with a claim worth paying close attention to: the first agentic capabilities in a major simulation platform. What does agentic mean here? It means that AI just doesn't speed up the work you're already doing. It independently explores design alternatives, such as structural, thermal, systems engineering. The AI iterates across multiple constraints simultaneously without you telling it what to test each time. So the direction is clear. You're moving from AI as a tool you operate to AI as a collaborator that you give objectives to. If the claim holds, AEC firms could compress design cycles from weeks to days. Story 5 is about one of the most labor-intensive workflows in the AEC industry: scan to BIM. Here's what scan to BIM traditionally looks like. You send a team to a site with a laser scanner. They capture a lot of data points. It's a point cloud of the space. Then a skilled operator spends days, sometimes weeks, manually classifying each object. Like, this is a wall, this is a pipe, this is a structure column. Only after all that work do you have a usable building model. According to GeoWeek News, AI is now automating that classification step. The point cloud goes in, the classified model comes out without the manual bottleneck in the middle. And alongside that, we're seeing what they call intent-driven GIS. Rather than manually chaining tools together, users simply describe the outcome they want, and AI determines the data sources and processing steps. The pattern across both: you stop operating tools and you start specifying outcomes. The final story for this week is about the venture capital infrastructure that's building under all of this. Mass Robotics, Boston Robotics Accelerator, has now passed $2 billion in cumulative startup funding since 2017. That's nearly a decade of concentrated investment in physical AI, and it's producing results. One of the most notable 2026 milestones is the Code Metal's $125 million unicorn round. Code Metal translates high-level programming code into hardware-specific instructions for robotics, defense, and automotive applications. Think of it as the translator layer between software engineers and the physical robots they're trying to build. As this infrastructure layer matures, deploying purpose-built construction robots becomes cheaper and faster. The $2 billion milestone matters because historically, this kind of foundational investment precedes a wave of application layer deployment in vertical industries, and construction is squarely in the firing line. So let me take a moment to zoom out and connect the dots on the macro picture. Everything we've seen this week is connected by a single feedback loop. The AI infrastructure boom is creating massive demand for physical construction at a scale the industry has never seen before. That demand makes construction robotics economically viable today for these hyperscale customers. Boston Dynamics robot dogs are the clearest example, but here's the second half of the loop. As these deployments scale, unit costs fall, and when unit costs fall, the same tools become accessible to ordinary construction sites, not just billion-dollar tech campuses. The data center boom is essentially funding the cost reduction that will eventually bring physical AI to every construction site. So let me leave you with the single idea I want you to take away from today. The R&D era for physical AI in construction is over. What we've seen this week, robot dogs commercially deployed, robotic prefab engineering funded pilots, autonomous drone robot fleets being deployed with industry partners, agentic engineering reaching major simulation platforms. These are not experiments. These are the opening moves of deployment at scale. The 94% of current AI users in AEC who plan to expand in 2026 are the early signal. The laggard majority is beginning to move.